So in this video we're going to have a look at double factorial. So n with 2 exclamation marks. Now we already know what n factorial is. So that's basically n times n minus 1 times n minus 2 all the way along and 2 times 1. So for example 6 factorial, that equals 6 times 5 times 4 times 3 times 2 times 1. We know that is 720. Okay, now what about the double factorial? Well, this one jumps every other integer. So here, if you did 6 double factorial, we'd have 6, the 4, the 2. So that's for even numbers. So for even numbers, so we could describe n as 2k. So n equals 2k, where k is some integer. That's the general accepted way to describe an even number. So in this case, n double factorial, which would equal 2k double factorial. Remember to put that in brackets, otherwise it just means 2 times k double factorial. This becomes 2k times 2k minus 2, 2k minus 4, and all the way along. And as it's even numbers, our last couple of numbers are going to be 4 and 2. So 4 and 2. So for example, if we did 8 double factorial, we'd write this as 8 times 6 times 4 times 2. So if we do our sums on this, 6 8s are 48, times 4, 192, times 2, 384. So that's 384. And then you could try a few other even number examples for yourself. Put the comments in below what you think you get. Now, that's all well and good with even numbers. What about odd numbers? So odd numbers. So the general accepted way of writing an odd number is n equals 2k plus 1. Again, where k is an integer. So now our n double factorial for odd numbers. So in this case, n double factorial equals 2k plus 1 double factorial. Again, take care to make sure that goes in brackets, otherwise that's going to confuse. So that equals 2k plus 1. So that's our first number, and then we need to subtract 2 every time. So if you subtract 2 off this, we get 2k minus 1, 2k minus 3, and so on. And then we multiply by 3 and by 1. That's our last 2 integers that we multiply this by. So let's have a look at 7 factorial. Very close to our 8, of course. So to calculate this, we do 7 times 5 times 3 times 1. 1 is trivial, but I've just included it there for now. So 7 5 is 35 times 3, that's 105. So that's our 7 double factorial. Now, is there a relationship between the single factorial and the double factorial? That's the question we want to know. So how we can write that is n factorial equals, so basically if you think about this, we've got our double factorial here and our double factorial there. We can write this as n double factorial times n minus 1 double factorial. And that's how we could put the relationship of the two together. So here for 8 factorial, we'd write 8 double factorial and then multiply that by our 7 double factorial. And 384 times 105. So what's that going to give us? 384 times 105 equals, so if you do your sums on that, because I know what 8 factorial is, you get 40,320, which would be the same as 8 double factorial. So that's what we got there. So now I'm going to just clean the board off and we're going to have a look at see if we can do some manipulatives on this algebra. Okay, So n factorial equals n double factorial multiplied by n minus 1 double factorial. So can we get this in terms of n double factorial? Well, of course we can. We can just divide both sides by n minus 1 double factorial. So if I bring this over this side, I've got n double factorial equals n factorial over n minus 1 double factorial. Let's just change something a little bit. Why don't we multiply both sides by n plus 1 and multiply this by n plus 1. Let's see what we can get there. So then we get n double factorial equals, well, n plus 1 times n factorial. That's just the same as n plus 1 factorial. And here n minus 1 double factorial multiplied by n plus 1. Well, that's a difference of 2. So we're still in terms of the double factorial. So we can rewrite this one also as n plus 1 double factorial. So that's quite an interesting relationship between the two of these here. So I'm just going to write that up here. So n double factorial equals n plus 1 factorial over n plus 1 double factorial. So that's quite an interesting relationship between the two of those. Okay, let's take this off the board and see if there's a general formula we can use without multiplying all the digits together. Okay, so there's a product formula we can use to make our formulas for double factorial. Now the product formula is like the capital pi. So pi, and we have for the even numbers 2k. So in here I've got 2a. And in this one, for the odd numbers, which are in the form of 2k plus 1, my formula here is 2a plus 1. So remember, this calculation of these functions here are very sensitive on the parity of the numbers. So that's why we have to have two different product formulas. And for our range of product, what we have is from a equals 1 to the number k. And the same here, a equals 1 to the k. Okay, so that's not really telling us much at the moment until we work out what our number is, and we'll see it in action. So for example, if we let n equal, for example, let's have it equal 6. So therefore our even number, 6, will equal 2k. So now solving for k, we know our k equals 3. So now writing our product formula, a equals 1 to 3, and then we've got 2a. So this now equals, so when a is 1, we've just got 2. When a is 2, we've now got 4. And when a is 3, we've got 6. And then we've got 2 times 4 times 6, 2 4s are 8, times 6, that's 48. So that would be our 6 double factorial. So that takes care of our even number. And you can try this for a lot of other numbers as well, so see how you get on with that. Now for odd numbers. So an example of an odd number, let's just use the number 5. So if n equals 5, which equals 2k plus 1. Solving for k, we can see that k equals 2. So now using that information, plug that into this product formula. So now the product is from a equals 1 to k, which is just 2. And then our 2a plus 1 is what our input is. Okay, so 2a plus 1. So if a is 1, our first one for the product would be 2 times 1 is 2, plus 1, that's 3. So then that would equal 3. And then our last one would be for 2. So 2 times 2 is 4 plus 1, that's going to give us 5. So 3 5's 15. And does that equal 5 double factorial? Well, it's 1 times 3 times 5. 1 is the trivial number because it doesn't make any difference on multiplication. Well, 3 5's are 15. So 5 double factorial is the same as 15. And then just to end that, I'm just going to write down a few areas of mathematics where this is used quite a lot. So combinatorics, it's very popular in that, working for combinations, in probability and stuff like that. And then also in the volume of a hypersphere. So it's used in that formula as well, and also in the representation in integrals of trig functions. So integral representation of trig functions. Okay, so that's the double factorial function.